All right, guys. We're back. Same worksheet again. Like it was 17 pages. So we're doing the same packet, and yeah, we should have completed the first three by yesterday. If you didn't get those in, please get those in as soon as possible. I imagine if you didn't get those in, you're probably not watching this video right now. So if you did get those in, here are the answers. Yeah. So here are the answers, just so you can check them to those first like three pages. Sorry, I'm going through them a little quick, but whatever. I know most of y'all did fine. Oh, this one right here, number 10. That one tripped up a lot of people. Not entirely sure why, but that was the most missed number or most missed question there. Just -2y to the third over xz. All right. So, as I said in the past video, what we're going to be doing is continuing on. And the next one is multiplying, but we're actually going to skip number 4. So, number 4 is one of those sheets we're not going to worry about. And we're going to go straight to number 5, multiplying and dividing. So, we can do multiplying and dividing. All right. So, if we're multiplying and dividing some fractions, well, let's think about it. These rational expressions are pretty much just the same as fractions. So if I have, let's say I have 1/2 times, let's go with 3/4. What I do is I just multiply straight across. Multiplying and dividing fractions, or multiplying fractions, is super easy. Dividing, pretty much the same thing. It's going to be easy. So all I do is multiply straight across with fractions. So I do 1 times 3. So let's see. I'll do 1 times 3 equals 3. And then I'll do 2 times 4 equals 8. So 1/2 times 3/4 is 3/8. That's how you multiply fractions. Pretty simple. Just multiply straight across. And if I'm dividing fractions, we're going to do something that hopefully y'all will remember. All right, so I will do, what will I do? Something similar. Let's say 4/5 divided by, no, I don't like 4/5. Never mind. Okay. Okay, so we will go 2/5 divided by 2/3. So when I divide fractions, it's again going to be pretty simple. All we have to do is remember one thing, and hopefully you remember this terminology or something similar to it, which is going to be keep, change, change. So it's getting harder to write on this thing. Flip. Keep, change, flip. That's how you divide fractions. Keep, change, flip. And what that means is we're going to, let's see, I'll draw some arrows in some different colors. I'll give it orange. So I keep the 2/5. I keep the first fraction. I change the sign, or I change the operation. Let's see, what is, that's a nice one. Okay, so I'm changing this division into multiplication. And flip means I flip the second fraction. Give me, oh. Okay, we'll go yellow. Okay, and then I flip this fraction here. Up there. Got really wobbly, but that's okay. Okay, dang it. Like I said, something is not working. Like my touch screen is going dead or something. Okay. Go down. Okay. So I keep change flip. Keep the first fraction, change it to multiplication, flip the second fraction. So once I do my keep change flip, I'll go back to my standard colors, my red. So now I'm going to have, I keep the 2/5. I change the division into multiplication, and I'm going to flip the second fraction. So now it's going to be 3/2 instead of 2/3. And this is just multiplication, and we know how to multiply fractions, so we multiply straight across. So 2/5 times 3/2. So let's see. 2 times 3 is going to give me 6. And 5 times 2 is going to give me 10. So 2/5 times 3/2 is 6/10. Or 2/5 divided by 2/3 is 6/10. And again, 6/10 simplifies to 3/5 because 6 is 3 times 2, 10 is 5 times 2. All right, so that's how we do it with normal fractions. And it's going to be the exact same for these rational expressions. So, let's see. I have 2a squared b times, or over b squared c times b over a. So all I'm going to do is just multiply straight across. So I'm going to do 2a squared b times b, and that's just going to give me 2a squared b squared, because I have b times b. And in my denominator, I'm going to have b squared c times a, which is going to be a b squared, b squared c. And now I have this new fraction, it's just one fraction, and now I'm going to do what I did on the first 3 pages and simplify it. So let's cancel out things we can cancel out. Let's see, I'll use red to do that. So I have b squared and b squared in both the numerator and the denominator. I have 2 a's in the numerator, but only 1 a in the denominator. So that a cancels out, but I'm still going to be left with 1a in the numerator. So this simplifies into, let's see, I'm left with 2a over c. And that's my entire answer. 2a over c for this one. All right, and that's all we really have to do here. And then let's look at number 2 here. So number 2, I have y squared minus 2y minus 15 over 4 times 8 over y plus 3. And I'm supposed to multiply straight across, which means I'm going to be multiplying y squared minus 2y minus 15 times 8. But I don't want to distribute that 8 to everything because I know some things are probably going to cancel out just like they did over here. So instead, what I'm going to do is I'm going to factor this y squared minus 2y minus 15 first. So when I do that, let's see, I'll bring it over here. I'm looking for 2 numbers that are going to multiply to be negative 15, but they're going to add up to be, negative 2. And those 2 numbers are going to be negative 5 and positive 3. Because negative 5 times 3 is negative 15, negative 5 plus 3 is negative 2. So now I'm factoring this y squared minus 2y minus 15. So I got, let's see, y squared minus 5y plus 3y minus 15 and then I group between y squared and negative 5y. I can pull out, can I? Okay, this isn't writing. I'm sorry. I'm not like, what is going on? So I'm left with y, parentheses, y minus 5. And then I have that 3y minus 15. And when I pull out the GCF is going to be 3. And I'm left with y minus 5. Which means that this y squared minus 2y minus 15 is going to turn into, God, okay. I am not enjoying this right now. Y plus 3 times y minus 5. Okay, so that's y plus 3 times y minus 5. Which means when I multiply everything together, I could distribute everything, like I said earlier, but I'd rather not. Instead, what I'm going to do is I'm just going to multiply everything together and leave it factored. So I'm going to have, well, y plus 3 times y minus 5 times 8 is going to be, I'll put the 8 in front. So 8 y plus 3 y minus 5. And then I have 4 times y plus 3. I'm just going to leave that as 4 y plus 3. And now I'm going to see what cancels out. So let's see. I have y plus 3 in both the numerator and denominator. Those are going to cancel out. And then, let's see, I can't get rid of that y minus 5, but I do have an 8 over 4. And 8 over 4 is 2. Which means I'm left with, I'll come down here, I guess. Okay, so I'm left with 2 over 1, or just 2 y minus 5. My denominator is gone, and since my denominator pretty much canceled out into 1, anything divided by 1 is itself, so I don't really need to have this as a fraction anymore. It's just 2y minus 5. And earlier, I did talk about how we could distribute, and this is where we're going to do that, because we're left with 2y minus 5, and to get my final answer, I just distribute that 2, and I'm left with 2y minus 10. That is my final answer. So y squared minus 2y minus 15 over 4 times 8 over y plus 3 is 2y minus 10. All right. So we're going to do the same thing with our fractions, or our division. My bad. Yeah, division. Wait, give me just a second. Sorry, checking on something. Okay, we're good. Yeah, we're good. Okay. So with our division problems, let's see, what do we have? We have x minus 5 over 6 divided by 2x minus 10 over 12. And what I'm going to do is the keep change flip. So I'm turning this into, instead, let's see, x minus 5 over 6. I keep the first fraction, change the operation, and flip the second fraction. So 12 over 2x minus 10. Okay, so the next thing I want to do is, well, just like when we had these problems at the top. So yeah, when I'm scrolling back up to, where's an example of it? What am I looking for? Okay, so like this one, number 2 here. where I did 2x plus 8 in the denominator, and one of my steps was pulling the 2 out, pulling out the GCF to turn that into 2 times x plus 4. That's exactly what I'm going to do here. So I need to pull out a GCF if there is any in the denominator. Or in the, not any in the denominator, in any binomials. So I have x minus 5, there's no GCF there. I have 6, I have 12, nothing is happening to those are just numbers. And then I have this 2x minus 10. And that 2x minus 10, I can turn that into 2 parentheses x minus 5. So I'm going to do that. If it'll let me. Okay. 2 parentheses x minus 5. All right, cool. So now I'm going to multiply straight across. So let's see, I got x minus 5 times 12 equals 12 x minus 5. And then I got 6 times 2 x minus 5. 6 times 2 is 12. And then I have x minus 5. And I'm left with 12x minus 5 over 12x mince 5. Cancel my things out. 12 over... Oh my god, this is not writing today. 12 over 12 cancels out. X minus 5 over x minus 5 cancels out. I'm left with nothing. My answer is not 0 though, because this is a number divided by itself. That's like saying 3 over 3. And 3 over 3 is not 0. 3 over 3 is 1. So my answer to this one is just 1. So x minus 5 over 6 divided by 2x minus 10 over 12 is 1. And I think we'll just do this whole page together probably. I'm looking at it, it doesn't look like it'll be too complex or tedious. Okay. All right, so we will just go with, number 4, get into it. So on this one, I don't see any polynomials, any quadratics, where I would have to factor it like I did with number 2. It is multiplication, so I don't need to keep change flip, but I do see some binomials, and I see some GCFs in those binomials. So let's turn this problem into something else. I'll come over here. So I got 5n plus 15. Well, 5n plus 15 is going to turn into 5 parentheses n plus 3. And then I have 4n plus 8. So I pull out the GCF, which is 4, and I'm left with, 4 n, gosh darn it, n plus 2. Okay, and then I'm multiplying that by, let's see, in the numerator over there, I have 2n plus 4, which is going to give me, this thing does not like me. Okay, that was writing with my finger, and that does a lot better instead of writing with the stylus. So I'm just going to write with my finger for the time being. Okay, so 2 parentheses. I put out the GCF of 2, and I'm left with x plus 2. That's so much better. Why haven't I been doing this all along? And then in my denominator, I have, let's see, 3n plus 9. The GCF is 3. Oh, it's n, not x. N plus 3. Okay, cool. So when we multiply everything together, we are going to have, let's see, multiply the top, multiply the bottom. That's going to give me 5 times 2 in the numerator is going to be 10. And then I have n plus 3, n plus 2. And then in my denominator, I'm going to have 4 times 3, which is going to be 12. And then I have n plus 2 times n plus 3. Just leave it factored like that. And then I can cancel out some terms. So I got n plus 3 over n plus 3 cancels out. N plus 2 over n plus 2 cancels out. All I'm left with is 10 over 12. And 10 over 12 is a fraction that's going to simplify because 2 goes into both 10 and 12. So my solution is not 10 over 12, it is 5 over 6. Because 10 divided by 2 is 5, 12 divided by 2 is 6. Here's my answer. 5/6. Which means 5n plus 15 over 4n plus 8 times 2n plus 4 over 3n plus 9 is 5/6. That's it. Cool. Okay, let's get on to number 5 then. This one is division, so first thing I'm going to do is keep, change, flip. So I got x squared minus 2x over 6. Keep the first fraction. Change the operation. You know what, I'll put that as like a dot instead of a x for times because that x might be confusing. I'll go back up and change it here too. Okay, yeah. And then change the operation to multiplication and then flip the second fraction. So we got x over 3x minus 6. All right, cool. Next thing we want to do, look for those binomials or trinomials that we can factor. I see 2 binomials, and it looks like both of them have GCFs. So this first binomial here is x squared minus 2x, which is going to turn into x parentheses x minus 2. Because if I distribute that x back in, I get x squared minus 2x. And then it's still over 6. And then times, let's see, I still have an x over there. And then 3x minus 6. So the GCF between 3x and negative 6 is going to be 3. So after 3x minus 2, because negative 6 divided by 3 is negative 2. And then multiply everything together. So let's see. I'll bring it down here and I'll make it green. So that equals, so I got x times x minus 2 times x, because I'm multiplying straight across. And that's going to give me, well, x times x is x squared times x minus 2. And in my denominator, I have 6 times 3 times x minus 2. 6 times 3 is 18. And then I have that x minus 2. And I cancel things out. The only thing I cancel out is x minus 2 over x minus 2. And all I'm left with is x squared over 18, which means my solution is x squared over 18. So yeah, x squared minus 2x over 6 divided by 3x minus 6 over x is x squared over 18. That's all we got to do. Ooh. Number 6 looks like it has a lot of steps. That's okay. I'll work real small. Okay. So first thing we want to do here is keep, change, flip. I'll literally make this as tiny as I can. Maybe not as tiny as I can. Just a little bit bigger. Okay. So let's see. Keep, change, flip. So that means I have... Ooh. I'll make that even smaller pen size. So yeah, m squared minus 2m minus 8 over 8m plus 24. Change the operation. So change it from division to multiplication. And I'm left with, in my numerator now, because I flip the second fraction, I have m squared plus 7m plus 12 over 2m minus 8. All right, Gucci. Okay, so I see two different quadratics here. And I'm not too keen on working with these quadratics, but I gotta do it. So let's see. We'll work with the first one, that m squared minus 2m minus 8. So I'm looking for two numbers that are going to multiply to be negative 8 and add up to be negative 2. Those two numbers are going to be negative 4, positive 2, which means this m squared minus 4m plus 2m, because negative 4 times 2 is negative 8, negative 4 plus 2 is negative 2, and then minus 8. And then I'm going to group. Look how much better this is going with my finger instead of that stylus. Okay, then I group, pull out the GCF. I got m squared minus 4m, which is going to give me m minus m, parentheses, m minus 4, and then plus 2 m minus 4. So the two factors of this are, what was it? Oh yeah, m plus 2 times m minus 4. Okay, so what I'm going to do with this now is I'm going to start to rewrite this here. So now that I got that m plus 2 over m minus 4, let's see, I'll take it here and I'll rewrite that in, these are some nice colors here. I like this turquoise. Okay, we'll rewrite this in this turquoise. Okay, so that's going to be m plus 2 times m minus 4 in my numerator of the first fraction. That's just the numerator of the first fraction. I know it's a lot. Okay. The denominator of the first fraction is 8m plus 24. The GCF between 8m and 24, it's not 4, it's actually 8, because 24 is divisible by 8. So this is going to be 8m plus 24 divided by 8 is 3. So that's what my first fraction converted into. And we are multiplying that by whatever our second fraction turns into. And let's figure that out right now. I'll go, not purple. I'll use a different shade of purple though. Okay. So I have m squared plus 7m plus 12. I'm trying to factor this one now. So let's see, two numbers that are going to multiply to be 12 and add to be 7. Those two numbers multiply to be 12, add to be 7. It's going to be 3 and 4. So let's see, that gives me m squared plus 3m plus 4m plus 12. And I group. So m squared plus 3m, take out the GCF, is m, left with m plus 3. Then 4m plus 12, take out the GCF of those, it's 4. I'm left with m plus 3, which means the two factors here are m plus 4 and m plus 3. Okay, cool. So I'm bringing that over here. I'll go back to that turquoise. Ooh, does that. So let's see. I said it was m plus 4 times m plus 3. Okay, cool. And then my denominator of the second fraction is 2m minus 8. The GCF between 2m and negative 8 is 2. So I pull out a 2. And I'm left with m minus 4. Because negative 8 divided by 2 is 4. Okay, now we can combine things. So let's see. When I do so, I'm going to have, well, just pretty much all these factors in the top, because I'm multiplying m plus 2 times m minus 4 times m plus 4 times m plus 3, which gives me just all that. M plus 2, m minus 4, m plus 4, m plus 3, all over, and then I have, in my denominators, I had 8 times m plus 3 times 2 times m minus 4. So 8 times 2 is 16, and then I'm going to have my m plus 3 and my m minus 4. Okay, so now that I have all this condensed into one fraction and everything's factored, I can cancel some things out finally. Okay, so I see an m minus 4 in both the numerator and denominator. I see m plus 3 in both the numerator and denominator. And nothing else is going to cancel out. So in the top, I'm left with m plus 2 times m plus 4. In the bottom, I'm left with 16. So, just like with, what was it, number 2, where we distributed that 2 back out, and I had to get that 2y minus 10, now I have to multiply this m plus 2 times this m plus 4. So m plus 2 times m plus 4, distribute, so I got m squared. M times 4 is 4m. 2 times m is 2m. 2 times 4 is 8. Combine like terms. That 4m plus 2m is 6m. So that's my new numerator. And my denominator, I just had 16. So this is my solution. I know that some people are going to see the 8 over 16 and going to be like, oh, I can simplify that. I can turn that 8 into a 1 and that 16 into a 2. No, you can't, because you got to divide everything by the 16. This is the answer. It's m squared plus 6m plus 8 over 16. Looking at this page pretty quickly, it looks like that is the worst problem on this page. So, ooh, actually, number 9 looks kind of awful too. But yeah, it's not going to be as, or number 9 is just as, maybe just as bad, don't know. But this is probably as bad as we're going to see. So that means m squared minus 2m minus 8 over 8m plus 24 divided by 2m minus 8 over m squared plus 7m plus 12 is m squared plus 6m plus 8 over 16. Awesome. That's all we got to do. Okay, so same thing here. We're just going to keep going. I'm just going through all of these. Okay, this one is multiplication, which means we don't have to keep change flip. We just go straight across. And the other thing I wanted to do was look for things I could take factors out of. So I see that 10x plus 20, the GCF between 10x and 20, I'll just keep using this maroon, it's kind of a nice color. So the GCF between 10x and 20 is going to be 10. So that is going to turn into, or this fraction is going to turn into x plus 3 over 10 x plus 2. And I'm multiplying that by x plus 2 over let's see. And then I have this x squared plus 4x plus 3. So I'll come over here to do that. I'm going to go back to that smaller size of pen. Okay, so x squared plus 4x plus 3. I want two numbers that are going to multiply to be 3 and add to be 4. Hopefully, y'all can figure out that it's going to be 3 and 1. So we got x squared plus 3x plus 1x plus 4. We group. Okay, so x squared plus 3x, the GCF is x. I'm left with x plus 3. And then between x and 4, there is no GCF, but I gotta pull something out, so I'll pull out 1. And I'm left with, oh wait, that didn't work. Oh, duh, okay, sorry. I know why it didn't work. It's because this should be a 3, not a 4. I'm left with x plus 3. Okay, yeah. And when I turn that into my factors, I got x plus 1 times x plus 3. So I'm using that x plus 1, x plus 3 over here. Okay, cool. Now I have my fully factored out two fractions. I'm just going to multiply straight across. So when I do that, I'll use a different color. I'll use this one. So I got x plus 3 times x plus 2. We're just going to leave that in factored form. X plus 3 times x plus 2. Then my denominator, I have 10 times x plus 2 times x plus 1 times x plus 3. When I just multiply straight across, yeah. I'm not going to distribute anything yet because I now need to cancel. I'll use this salmon color. Okay, I got, I see an x plus 2 and an x plus 2 in both numerator and denominator. I see the x plus 3 in both the numerator and denominator. I don't got anything left in my numerator. But, again, it doesn't turn into 0 because when everything cancels out in these multiplication problems, it turns into 1. Which means my numerator is now 1. Yeah, 1 over, and then I have a 10 and an x plus 1 in my denominator. But just like with problem number 2 and problem number 6, I have to multiply these two together now. So I have to multiply 10 times x plus 1. And I'm just going to turn that denominator now. If I distribute the 10 times x plus 1, it's going to be 10x plus 10. So the solution to x plus 3 over 10x plus 20 times x plus 2 over x squared plus 4x plus 3 is 1 over 10x plus 10. And I'll put a box around that, because why not? Okay, cool. On to the next one. I know I'm kind of just working through these. I just want you guys to get a feel of like how they work. And I know I'm going a little quick. It's just because there's, how many are there on this page? 12. Okay, yeah. Okay. So let's see. This is division. First thing I want to do, keep, change, flip. So I'll do that over here, I guess. Yeah, I will. Keep the first fraction the same, x squared minus x minus 12 over x minus 4. Change the operation from division to multiplication, and then flip the second fraction. You only keep, change, flip with division. Okay, so now I have that. I kept the first fraction the exact same, changed the sign to multiplication, and now I flipped the second fraction. So next thing I'm looking for is things I can factor. the denominator of the first fraction can't be factored, or can't be, not factored. I guess it is factored. Can't be simplified, I guess, yeah. No, it can't be factored because there is no GCF between x and -4. Same with x and -5 in the numerator of the second fraction. So that's not gonna work, but this x squared minus x minus 12 can be factored, and so can that 2x plus 6. So let's do so. Let's see, I got x squared minus x minus 12. So I'm looking for two numbers that are going to multiply to be -12, but add up to be -1. So these numbers multiply to be -12, add to be -1. I believe that is -4 and 3. Yeah, -4 and 3. So I got x squared minus 4x plus 3x minus 12. I group. So between x squared and -4x, I got x times x minus 4. And then between 3x and -12, the GCF is 3. Which means my two factors are x plus 3 and x minus 4. So I rewrite this. So my new numerator, I'll rewrite it in a different color. I'll use this one. So that's going to be x plus 3 times x minus 4 over, and then like I said, my denominator there on that first fraction can't be, I can't do anything with that. That just stayed x minus 4. And then I have in my second fraction, the numerator there, that x minus 5, can't change that either. So that stays x minus 5. And then I have 2x plus 6. That is just a binomial, and I can factor that pretty easily because the GCF between 2x and 6 is just 2. So I got 2x plus 3. And now there comes the easy part of just multiplying it all together. So I got x plus 3 times x minus 4 times x minus 5. It's going to be just that. So x plus 3 times x minus 4 times x minus 5. And then I have x minus 4 times 2 times x plus 3. So I'm just going to put that 2 out front. And then I have x minus 4, and it was what? X plus 3? Yeah, x plus 3. So now I have this. I'll just cancel things out. Let's see, x plus 3 in both the numerator and denominator. X minus 4 in both the numerator and the denominator. Which means I'm left with x minus 5 over 2. So the answer is that. It is x minus 5 over 2. And there's nothing to distribute in either numerator or denominator. That's it. X minus 5 over 2. So x squared minus x minus 12 over x minus 4 divided by 2x plus 6 over x minus 5 is x minus 5 over 2. All right, cool. And here's number 9. Number 9 doesn't look very nice at all. Okay, we'll do it anyways. Okay, number 9 is just going to be pretty much the same thing as number 6, which wasn't a nice problem. But it is division. So what was the first thing I did there? I did the keep change flip. Okay, so keep the first fraction the same. So that's going to give me x squared minus 5x minus 6 over 5x plus 15. Change the operation from division to multiplication, and then flip the second fraction. So that gives me 7x plus 21 over x squared minus 3x minus 4. So there's my keep, change, flip. Keep, change, flip. Yeah, that's how we do multiplication of fractions. The other thing, oh, I forgot to mention this. You might know multiplication of fractions as cross multiplying. That works fine too. Trying to think. Yeah, the one thing you want to watch out for with cross multiplying is making sure you get the right thing in the numerator and one right thing in the denominator. That's why I just prefer to keep, change, flip, because it's just like flipping the second fraction and then just multiplying straight across. So pretty simple. All right, now both numerators and both denominators can be factored in this problem. So we got to do it. First thing I'll do x squared minus 5x minus 6. I'm looking for two numbers that are going to multiply to be negative 6, and they're going to add to be negative 5. Those two numbers that multiply to be negative 6, but add to be negative 5, it's not going to be 2 and 3. It's not going to be negative 2, negative 3. Because negative 2 times negative 3, even though that does add to be negative 5, it multiplies to be positive 6. So it's actually going to be negative 6 and 1, because negative 6 times 1 is negative 6, negative 6 plus 1 is negative 5. So I got x squared minus 6x plus 1x. Okay, there's something on the screen, sorry. Okay. And then what is it, minus 6? Yeah, and then I pull out the GCF between x squared and negative 6x. It is x. I don't know if it's x minus 6. And between x and negative 6, there is no GCF. So I still have to pull out something. That something is 1. X minus 6. And then that means my two factors here are x plus 1 times x minus 6. I'm going to come over here and put that into the numerator of that first fraction. Which color do I even? I'll use this one. Okay. So x plus 1 times x minus 6 is the numerator of the first fraction. The denominator of the first fraction, I got 5x plus 15. That's a binomial. That's pretty simple to factor. So the GCF between 5x and 15 is 5. So I got 5, and let's see, 5x divided by 5 is x, 15 divided by 5 is 3. So there's my first fraction. It turned into that. My second fraction, I have times, let's see, in the numerator I got 7x plus 21. The GCF between 7 and 20, or 7x and 21 is 7. So I can pull out a 7, and I'm left with, well, 7x divided by 7 is x, 21 divided by 7 is 3. And then I have that x squared minus 3x minus 4. So let's come over here to figure this one out. I want two numbers that are going to multiply to be negative 4, but add to be negative 3. And just like with that negative 6 and negative 5, we need to watch out with this one. It's going to be negative 4 and 1. So I got x squared minus 3x minus 4 turns into x squared minus 4x plus 1x minus 3. Not minus 3, minus 4. I did that one on the last problem too. Or not the last problem, but a couple problems ago. Then I group. Okay, so then I have x squared minus 4x. The GCF between x squared and 4x is x. and I'm left with x minus 4. And then I have this x minus 4. There is no GCF there, so I have to pull out something anyways. That something is 1. I'm left with x minus 4, which means my two factors here are x plus 1 and x minus 4. So we'll put those over here. All right, so now I have this big fraction. Got to multiply everything together. Or I have these two fractions, I got to multiply them together into one big fraction. I'll use this one in yellow. Okay, so that's going to give me the first part. No, I want to put my numbers out front, and my just plain number when I multiply everything in the numerators together is 7, which means I'm going to have 7 x plus 1 x minus 6 x plus 3 over, and then let's see what's in my denominator. My 5 is already out front. 5 times x plus 3 times x plus 1 times x minus 4. And let's cancel out what we can cancel out. So many color choices. Okay, so let's see, what can I cancel out? I see an x plus 1 in both the numerator and denominator. And I see x plus 3 in both the numerator and denominator. And that's all I can cancel out. So this is turning into 7 parentheses x minus 6 over 5 parentheses x minus 4. And the last step is distribute. So let's see. Yeah, I got to distribute that 7, got to distribute that 5. So the solution, 7 times x is, no, I won't even bother using a different color. It's going to be 7x. 7 times negative 6 is negative 42. And then over, let's see, 5 times x is 5x. 5 times negative 4 is negative 20. So that means x squared minus 5x minus 6 over 5x plus 15 divided by x squared minus 3x minus 4 over 7x plus 21 is 7x minus 42 over 5x minus 20. That's it. Can't be simplified anymore. That's my entire answer. I know that one was a long problem. It's okay. Ooh. Okay, yeah, just looking at those. Sorry. Okay. Back to what we were doing. Next problem was number 10. All right. So here, we'll just multiply straight across. There's multiplication, and there's not really anything I'm gonna be able to factor out, so I'm not going to. Let's see. So yeah, I'm multiplying straight across. It's multiplication, so I just multiply those. So, 24 times 15. This is going to be the problem with this problem, those big numbers. So 24 times 15 is 360. I don't like that number. I do like that number, I just don't like the way I wrote it. My bad. Okay. Then I have x to the third times y squared. So x to the third, y squared, over, and then I got 25 times 8 is 200. And then I have x squared times y to the fifth. Okay, so this is just like with those problems we did the other day, or yesterday, or whenever you did them. I just can simplify things. I have those rules of exponents, and I have 3 x's in the top, 2 x's in the bottom, which means in the end I'm going to have 1 x in the top. And, you know, same with the y's, I'm going to do the same thing. But first thing I want to look at is this 360 over 200. So let's see. First thing I see, both these are divisible by 10. So 360 over 200. My bad. Okay. I'm just going to come down here to work with that fraction. 360 over 200 simplifies to 36 over 20. Another thing I noticed is that 36 and 20 are both even numbers, so I'm going to divide them both by 2. This is just how I simplify fractions. So 36 divided by 2 is 18. 20 divided by 2 is 10. Once again, I know 18 and 10 have a GCF. It is going to be 2. So once I pull out another 2, I'm left with 18 divided by 2 is 9. 10 over 2 is 5. So it's 9/5. 360 over 200 simplifies to 9/5. And I will cut. Ooh. Nope. Undo that. Wait, did I do that? God, okay, I don't know what's going on right now. Yeah, I just want to cut this and like scoot it over a little bit. Okay, yeah. Okay, so I got 360 over 200. I'm sorry. This is taking a bit. I'm a little out of it today. Whatever. So I got my fractions. I got 9 over 5. I probably don't need my bar to be that long. Okay, so I got 9 over 5. Because 360 over 200 goes to 9 over 5. And then I had x to the third over x squared. Well, there's 3 x's in the top, 2 x's in the bottom, which means 2 x's cancel out in both, and I'm left with 1 x in the top. And then I have y squared over y to the 5th, 2 y's in the top, 5 y's in the bottom. It's going to leave me with 3 y's in the bottom. So y to the 3rd. So that's my entire answer. 24x to the 3rd over 25y to the 5th times 15y squared over 8x squared is 9x over 5y cubed. That's it. That one was a pretty simple one. Okay, we'll keep going. There's only 2 more on here. And then once I'm done these 2, y'all are on your own to do your own thing. So let's see. This one, pretty simple, pretty easy, because I don't have any quadratics I'm working with. I just have 2 different binomials, and I can factor them both. So let's see, 6x minus 18. I'll use a different color, because I just used the entire... I didn't circle my answer, or box my answer, I guess. I need to do that. Okay, and I'll use this nice lavender color. Okay, so let's see. 6x minus 18. The GCF between 6x and negative 18 is 6. I'm left with x minus 3 over 4x. That's what my first fraction converts into. My second fraction, I have x over, and then 2x minus 6. So the GCF between 2x and negative 6 is 2. I'm left with x minus 3. Yes. And then this is where I just combine everything together. And once I do so, I got 6 times x minus 3 times x. It's going to give me 6x times x minus 3. Yeah, in my denominator. My numerator is going to be 6x times x minus 3. My denominator, I got 4x times 2 times x minus 3. So 4x times 2 is 8x times x minus 3. And then we will cancel some things out. So x minus 3 and x minus 3 cancel out. And then I have an x and an x canceling out. And I'm just going to 6 over 8. 6 over 8, hopefully we recognize that that fraction is 3/4. So 6x minus 18 over 4x times x over 2x minus 6 is just 3/4. That's it. Yeah, no. Why did I... Oop. I'm still getting the hang of this. Okay. Okay. Finally, number 12. So let's see. Again, no quadratics, thankfully. But this is a division problem, so we're going to keep change flip. So let's see. I got 3x plus 12 over 12x. Change it to multiplication and then flip the second one. So I got 48x cubed over, what is it, x plus 4, yeah. X plus 4. Cool. And now I can multiply. Actually, no, I can't because I have one thing that I need to factor. It's the numerator of the first fraction. That 3x plus 12, I'm turning that into 3 times x plus 4. Because that's just how it factors out. Over 12x times 48x to the third over x plus 4. Okay, cool. What else do I need to do here? Next thing I need to do is just multiply straight across. So I got 3 times x plus 4 times 48 times x cubed. So let's see, what's 3 times 48? This is 144. So that gives me 144. And then I have that x cubed. And then I have x plus 4. And in my denominator, I'm going to have 12x times x plus 4. Cancel things out because this is all turned into one big fraction now. X plus 4 of x plus 4 cancels out. I have x to the third divided by x is going to be x squared. So I'm going to come over here. Oh yeah, I got x squared in my numerator. And then I have 144 over 12. Well, hopefully we recognize that 144 is 12 squared. So 12 times 12 is 144, meaning 144 divided by 12 is 12. And that gets rid of, I'm not exactly canceling out that 3, so I won't actually cancel it out. I'll just turn that into 2. And 144 over 12, yeah. Okay. So that gets rid of everything in my denominator. And all I'm left with is 12x squared in my numerator. And is 12x squared over 1? I can write that as over 1, but I don't need to. It's just 12x squared. So that's the answer. 3x plus 12 over 12x divided by x plus 4 over 48x cubed is 12x squared. That's all. Okay, so now here's what I want you to do. We just did worksheet number 5 here. Do I want you to do 6? I don't think so. Okay, I want you guys to do 7 and 8. Don't worry about 6, but do 7 and 8. Okay. So, yes. I'll put a star at 7. That's not even a star. Okay, star at 8. Yes. These are what we're working on for the next assignment, and I would like them turned in I believe Monday or Tuesday. And I will post the same thing on Schoology, an assessment. Even though I'm calling it an assessment, it's not a test. Don't worry about that. I know a couple of people were like, oh my God, it's a test. No, it's not a test. It's not a test. It's not a quiz. It's just an assessment. It is a tool used to assess your knowledge on the topic that I've been teaching you. So therefore, it's an assessment. Yeah, it's just counting as the same, like a classwork grade pretty much. So yeah, 7 and 8. Don't worry about 6. Don't worry about 4. If you have any questions, let me know. As always, keep it up, guys.